Hello everyone, welcome to Geeks for Geeks. Can everybody tell me, like, I'm audible as well as visible to you? Can anyone confirm in the chat, like, it's audible? Okay, thank you so much. Let's discuss our today's Job-A-Thon post analysis, right? So, before starting it, let me introduce myself. So, my name is Nitin Kaplas, and currently I'm mentor at Geeks for Geeks. Today's analysis will be taken by me. Okay, so let's start it. Before starting it, can you guys please share me in the chat, like, how was it your today's Job-A-Thon? Like, how many questions you have solved? Like, in today's we have three questions. How was your questions and how many are you able to solve? Okay, okay. I hope all are like there in a live session. So before starting our today's analysis, so let me tell you, like, right now in GFG there will be a very good offers, right? So, like, for example, if you guys are not able to perform well in today's jobathon, right? If you have a little bit confident in that part, so let me tell you, like, right now there is very much good offers, right? So you can practice your DSLGO part, right, in a GFG courses. Okay, so there are multiple courses, like, you can take a live session as well, like, one-to-one session will be there, right? If you have any doubt in that part, so you can directly ask from your particular mentor at that time. Okay, so that will be the live sessions, right? So where you are interacting with your mentor, right? So that will be the live sessions, right? And if you are comfortable with the pre-recorded part, so there are also pre-recorded session as well, right? Which is recorded by our, like, Sandeep sir. Okay, so which is CEO of the GFG. So that will be recorded by itself. Okay, so yeah, it's very good recorded sessions as well as the live session as well. Okay, so in the live session also you get the recorded part. Okay, so both the courses are there in a GFG website, so you can check for that. And there is a as I already tell you, like, having multiple offers will be there, right? So let me share in the chat if anyone want to apply, right? So that will be the coupon code, right, which gives you about 30 to 35% off, right? So yeah, so that's all from my side for that case. So let's first analysis today's questions. Okay, so let me share my screen, so please confirm, like, it's visible to you or not. So please confirm in the chat so that I can start. Like, my screen is visible to you now. Okay, thank you, Deepak. Okay, so let's start with our today's first question. So our first question is modify max, right? So let's first understand that question. So what's the question said? You are given a non-negative integer array, right, which is ARR of length n. Okay, so you have to remove minimum number of elements from the array such that MEX value of the updated array is not equal to MEX value of the original array, right? So if it's not possible to update the max value, right, then we have to return -1 in that case. Okay, so let's understand first what's the meaning of MEX. So MEX is just a smallest positive integer that is not present in the array, right? And if the max of an empty array will be 0, right? If it's the array will be empty, so max will be 0, right? So here, if you see the first example, so let me first tell you a bit of, let's first do a dry run of couple of cases so that you understand what's the meaning of max. So let's first understand. Okay, so if you have the array like this, for example, you have 0, 1, 2, 3. So can you tell me, like in a chart, what's the MEX value? What is the MEX value for that particular array? Like the original, before removing any elements. Okay, so let me tell you. So yeah, it's the first question. Okay, so we just go with the flow of it, right? So we have three questions. So first will be the first question. Okay, so MEX value, as the definition of it tell us that key that is the smallest number that is not present in the array, right? If you see here, 0, 1, 2, 3 already present in your array. So what is the maximum value? Sorry, minimum value which is not in the present, which is not in the array. It's 4 now, right? For example, your value is array should look like this. 1, 2, 3 will be there. So what is MEX value? Smallest value which is not present in the array. So it's 0, right? It's 0. Smallest positive value which is 0. So these are the two things which you have to know, right, before solving the question. Okay. So how we can calculate the max value, MEX value. Okay. Now, if you see the first case, this case, let's do the drawing for this case. It's 0, 1, 2, 2, 3, 5. 0, 1, 2, 2, 3, 5. Okay. So if you have this array, okay. So what is the MEX value? Original MEX value before any removal. Okay. So 0 is there, 1 is there, 2 is there, 3 is there. So MEX value is 4. Smallest value which is not present in the array. Okay. Now, after removal it, how many elements we have to remove so that I can update my max value, right? I can update my max value. So here we have the updated value. Now, just think about it, like how we can solve this, right? Before this, let me give you this case. Suppose that your array will be this. Your array will be this. Okay. Now, my original value is, max value is, so our value will start from 0 to n, right? Which will be the positive value. So MEX value is right now is 0, right? Which is original. Now, when I update my array, when I delete some elements from my array, now what will be my max value? Now, let's do the couple of things. So if I delete this element, now just check what is your minimum value which is not present in your array. Yeah, it is 0, right? If I delete one, okay. But the question itself tell you that when you update it now, it's not equal to your original value. Your max will not equal to your original value. That two values, original and updated value, that should not be same, right? So if I do one, it's not, it will be same, right? So it's not the correct way to delete. If I delete this again, how many elements you have? 1, 3, 4. Now what is the minimum value which is not present in your array? It's again 0, right? It's again 0. So in this case also, your answer will be not correct, right? Again, similarly, if I delete 3 and 4 now, again, your maximum value, max value of the updated value after updating this is 0. So in this case, my answer will be -1, right? -1. That's the base case of it, right? I hope you understand this case. Okay. Now let's do our original test case. Okay. So in this case, how we can solve this question? As the question said, we have to delete the minimum values, right? Minimum value we have to delete. So here what I am doing is I just make a map, right? I just make a map, or we can make a vector. In the vector part, what I'm doing is I simply make a count variable of n size, and right now all the elements count will be 0, right? So what will be the n here? 6. So in this case, what I'm doing is I just make this vector, all are 0 right now. Okay, so let's do the dry run of this case. Like, let's traverse this array. Now if you see, 0 is there. Okay, so 0 is there. How many times? Just increment the frequency. Here also 1. How many times? 1 time. 2, 2 times. 3, 1 times. 5, 1 time. Now 4 remain the 0, right? Now, that's the first step. Okay, that's the first step you have to do. After that, what we have to do is, it's very simple. Let's make my answer. What's your worst case answer? Like, I delete all the elements. I remove all the elements. Means n. My answer in the worst case, it's n. You can also take like infinite, right? So let's take that answer which will be in my range, right? So that's why I take the n, right? Now, what we have to do is I simply traverse this count vector, and I'm asking it, right? I'm asking it while traversing this, I equal to 0 up to n. Here I'm asking if your count of I, if it's equal to 0 now, simply break that loop, right? And whatever stored in your answer, just return that. Just return that. Why? Let me tell you when we reach 0. Okay. Now, if we are I equal to 0, right? We are at here. We are at here. Okay. Now, see this case. Is this 0? It's not. It's not. So, what we have to do is, let's update my answer. Answer is minimum of answer or count of I, right? Why? Because if you see here, right now my answer is 6, right? I am deleting all the elements. But if I am reaching to first case, I see, okay, so 0 ka count is 1, right? If I delete 0 from here, let's suppose if I delete 0 from here, now my original value max will be, in this case, is 4, right? Before updating my array, right? Before deleting it, it's 4. If I'm deleting this, what is the minimum value? Minimum value itself is 0, right? If I delete this, 1, 2, 2, 3, 5 is there, right? After updating it, what your MEX value? It's 0. It's not match, right? It's not match. That's the condition of us. Okay. It's not match. And my answer is 6. So what I'm doing is I just update. What's the count of it? It's 1. Okay. So I have to delete only one element so that my original value of max and my updated value of max, that will be mismatched. That's the condition of us, right? So yeah, here when I'm here, I simply updating it, right? After it, when I move forward, okay, I equal to 1. Again, I saw like its count is 1, right? Its count is 1. So in that case also, what we have to do is, it's 0, it's not. Now, here again I update the value. So I am no need to update because it's 1, it's already 1, right? Again, when I go further, it's 2. No need to update it, right? Here it's 1, no need to update it. Now, when I am reaching at 0, right? When I am reaching at 0, okay. So here we have to break and return what value is stored in your answer, right? That will be your answer. So what is my answer here? It's 1, right? We have to delete only one thing. Either this, either this, either this, right? Now the question arises like, okay, so code is okay, but why we are writing a condition? Why we are writing the checkpoint like that? Ki when the count I equal to 0, we have to break, right? Suppose that I'm not writing this, right? Suppose that I'm not writing this. Okay. Now, if you see here, let me update my max value here. It's 0. Now, your previous value of max is 4, right? If I am not updating this, right? For example, okay, so I'm not here, I am here because nothing is there, right? Nothing is there. Okay. Now, when I reach to 1, I know that like 1 frequency is also 1, right? 5 key frequency is also 1. Now, why I'm not deleting this? Why I'm not deleting this? So suppose that, let's suppose for a second, like if I'm deleting this, what is my max value? I'm asking from you, like, think about it. What's my max value? Now, 0 is there, 1 is there, 2 is there, 3 is there, right? If I want, what is max? Smallest value, positive value, which is not in your array. So that will be 4 now. If you see, that will be 4, right? That will be 4. So 4, original value is 4, updated value is 4. Our quotient condition is that your updated value and your original value, that will be mismatched, right? So that's why this condition is there. So no need to go further. When you reach I equal to 0, hey, please stop there, right? Whatever you stored in your answer, just return that, right? So that's the simple idea to solve this question. Okay, so let's see the code. So the code is simple, like what I am written in that uh, part. So what we have to do is, let's focus, let's make the count vector, which right now is 0, right? Here I am doing the checkpoint. If x is in the range of n, so let's go to the like count part and just increase its frequency, right? After that, here, as I already tell you, like if your count of 0 already 0, it means that that particular element 0 is not present in your original array, right? If 0 is not present, so that will be x will be your 0 before updating your array, right? After that, if it's not there, you delete any value, right? After deleting any value, your updated value of max is also that, right? So that's why if my count of 0 is 0, I simply return -1, right? So that's the case of your sample 2, right? Just do the dry run for that case, right? So it's very simple. Okay, so if you see here, your count is 0, so just that max original value and updated value will be same, so that's why you just return the -1 in that case, right? After that, here I already tell you, like I just stored my answer as n, right? That's the worst case, and I just traverse the loop, and here the checkpoint is. If it's equal to 0, just break that point, and whatever is stored in your answer variable, just return that, right? So that's a simple idea to solve that question. So what's the time complexity of this? So yeah, the space is we are using n, and here we are traversing our loop, and after that again we are traversing our loop. So it's big of 2 into n, which we can say that it's big of n. So the time complexity is big of 2 into n, right? Which we can say that it's big of n, and the space we are using here is big of n, right? That's the idea to solve that question. So simple is like what's your max value original, that will be mismatched with while updating your answer, right? After that, what you are stored in your answer variable, you just have to return that answer variable. So yeah, the first question is over. Okay. So if you understood this first solution, please give me a +1. Okay. Okay, so let's move to our next question. Okay, so let's see how we can solve this question. Right, it's a sub problem of some other problem, right? Yeah, it's very simple but a little bit tricky. So let's understand how we can solve. So see here, we are given the array, right, which is of size n, and our integer k is given to us. We just have to return the count of pairs. Here the sum of I plus j, right, is due like k, right? And at the same time, these three conditions will be satisfied. The first is like both the values will be same. Array I equal to array j, and always I should be less than j, right? And at the same time, I plus j is due like k, right? So you just have to assume the one base indexing, and if your answer will be very large, so you just take the modulo of it and return that, right? So that's the question. Okay, I hope the question is very straightforward. Now let's understand how we can solve this. 1, 2, 3, 1, right? So this is my array, right? Okay. Now what we have to do is we are the three conditions. First is array I should be equal to array of j. That's the first condition. Second is I should be less than j, right? The third is I plus j modulo of k will be divisible by k, right? So it means its modulo will be equal to 0. That's the three conditions, right? Now, how we can solve this question? So what we have to do is I'm simply making a map of where the key is integer and value is vector, right? That we have to make. Okay. So means what I'm doing is in the first step, I simply segregate all the elements based upon the value of first condition, right? Both should be equal to 1. So what I'm doing is I'm simply make a map, right? Now I'm traversing over here. Hey, its value is 1. Okay, yeah, its value is 1. So what I'm doing is the value is 1, right? Now the value is 1. Yeah, its value is 1. So what I'm doing is the key is 1. Now what is an index? As in the question said, you have to take, you just assume the one base indexing, right? So that's I'm assuming it, right? So what's the index here? It's 0. So what I'm doing is I simply add 0 plus 1 so that I can make it as a one base indexing, right? Now let's move forward. Here we have the value 2. Okay, yeah, value is 2. Now what's the index? It's 1. So let's make it one base, right? Again I go forward. The value is 3. Okay, what's the index? It's 3. Again I move forward. The value is 2. What's the index? 4. Let me add here. That's why the key is in type and values of vector type so that I can store multiple values, right? Now after that we have 1. Okay, so value is 1. It means the key is 1, right? What's the index here? It's 4, means 5 if I do that. So if you see clearly what I'm doing in the first step, I simply make a map and store all the values. Like this is the value, this is the value, this is the value. So if you see here, yeah, 1, all the 1 index will be this 1 and 5. Yeah, 1 and 5. Okay, so 2. It's 2 and 4. So here we have 2, here we have 4. 3. Okay, so 3 index will be 3. The first step is satisfied, right? Second step is also satisfied. Why? Because my I is this, my J is this. Because I just make it at in the increasing order, right? Hope you understand because here I'm storing based upon my index, right? Index also in the sorted way, right? So second step is also satisfied. Okay, now the main target is like I just want what I want. I simply want key pair should be divisible by k. Okay. Now I plus j. If you see here, the first step is over, second is over. Now my main target is like I just want to add and check it's working fine or not. But if you see here, that example is very short, right? Here I'm adding like here we have two values which have the value 1, right? Two index which have the value 1. So we have the multiple values. We have the 5, 6, 7, 8 values which having the value 1, right? Index, right? So how we can solve this? That's why we just take the vector, right? Don't assume like it's a pair. It's a multiple values. It's a vector value, right? Okay, it's a list, a big list, right? Now, what I'm doing is I'm simply traverse on uh, this map, right? Inside this map, what I'm doing is I simply point on the particular first vector, right? I'm simply point on the first vector. So here in this case, what I'm doing is what is my vector? First vector, right? Which is this. So let's suppose its name is T, right? Its name is T. Now here I am written. Let me write the just a pseudo code. So here I have T, which is pointing to x dot second, right? It's pointing to x dot second. So T is pointing to this vector, right? Okay. Now inside this, what we have to do is, let's make a map. I simply make a map, right, which is of intent type. Let me name as MAP, right, because we already use M for that case, right? So inside this, now what we have to do is, again, we just traverse over our whole this vector, that particular vector. Let's suppose it's Y, and I'm pointing on MAP, right? Okay, now I want J, right? Now if you think about it, what's the value first? Let me write here int J. Int J is your Y, okay? Because Y is pointing to this right now, right? If you see here, Y is pointing to, okay, so it's not pointing to map, it's pointing to T, right? Because that's a vector. Okay, it's pointing to T. Now J is Y. What is Y? It's 1, right? Let's take the modulo of it so that it will be in the range. Modulo of K, right? Now 1 ka modulo of 3 is, here a value is 3, right? Is 1, right? I know that. Now I have a map here, right? I have a map here. MAP, now MAP, right? I am just asking, like, if my J is 1, what will be my I value? Because I want that will be divisible by K. Now, as I already take the modulo, no need to modulo. I want this will be equal to K. Okay, my J value is 1. So, what is my I value? I value is, if you see here, K minus J ka modulo. So, K minus J. See here, we have J, and now I just want K. I is K minus J, right? So, what is K? K is 3. What is J? 1. So, my I is 2. Now, I am asking, currently I am standing at J value. Now, I'm asking to my map, hey, you have the I value. I'm asking, m dot find I is there or not? Is not equal to m dot end. It means that value is present in there. But if you see that, no, nothing is there, right? Nothing is there. So nothing is there. What we have to do is, nothing is there. What we have to do? We simply go into the loop, go into the map, right? Which is map. Simply add j plus plus. Okay, so your I, so your 2 is not present. So simply add this. 1 is there. How many times? 1 time, right? Okay, now when I move forward, I am at 5, right? So what's the value of j? Y ka modulo of k means 5 modulo k, which is 2, right? We have 2 right now. Now I is j minus k. So sorry, k minus j. So what is k? K is 3. So if I make here 3 minus j, which is 2, which is 1. So let me write here 1. Now I have 2 because 5 ka modulo of k is 2, right? Now I am asking, hey, I am standing at j. So I just want to ask to map, my map, MAP map, ki I is present or not. They tell, yeah, 1 is present, means I is present in your map. How many times? Simply add how many times. How many times? It's 1 time, right? It's 1 time. So here my answer is 1 right now. Because if you see here, my j is this, my k is I is this. I have j. I am asking k minus j is present in your map. Yes, it is present. How many times? What's the frequency of it? It's 1 time. So what we have to do is, after that, if you see here, I am taking j as 2 and I as 1. Yeah, it's, if I add these two values, it's equal to k. Okay, so if I not take the modulo, already it's working fine, right? Okay. Now after that, what we have to do? What is my j? It's 2. Let's do plus plus, right? So till now, if anyone want to ask, okay, so don't say we could travel in each map index to show the answer by checking the index of key value. Okay, so let's see here. Now, after that, 1 and 5 already processed, right? My first vector is completed, right? My first vector is completed. And if you see clearly, my this value, 1 and 5, right? The index part, 1 and 5, both are equal. And both the indexing part, I plus j, is due like k, right? So we have the first value which I stored in here, right? I just want the count of pairs, right? So here I am making it. Okay. After that, if you see here, my outer loop, sorry, inner loop will finish, right? Because you are traverse all the values in a particular vector. Now, if you see here, my x is pointing to this set, right? So again, my t vector of t is pointing to x dot second, means this. Now your t will make this, which is 2 and 4, right? Again, I make a map, right? Again, I make a map. Now your map will be this. Okay. Again, your y is pointing to this case, right? So what's your value of j right now? Currently value of j, 2 ka modulo k, which is 2 itself, right? Now, I have 2. I want k minus j. Is there or not? So what is k? 3. What is j? 2. So 3 minus 2 is not present, right? Because my map is empty right now. So if condition is not satisfied, simply go to the map and increment your value. What is your value? 2. Your original value is 2. Please carefully see. Your original value is 2, where you are currently present. But you are asking k minus j is present in the left direction or not? It's not, because their map is empty. So simply I incremented my this. After that, I move forward and my j value is, so yeah, 4 key modulo of 3, which is 1. So your j is 1. Now I am searching 3 minus 1, which is 2. I have the 1, but I am searching. Hey, 2 is present in your map. Yes, it is. Okay, 2 is present if you see here. So if it's present, simply add that particular frequency of that particular element. So 2 key frequency is 1. So that's why I'm incremented as a 2, right? So your previous answer is 1 and right now its frequency is 1. So I'm adding as 2, right? And after that, what I'm doing is I simply make a count of it, right? So in that case, how many pairs you have? 2 plus 4. I know that, yeah, it's modulo of k, right? But as I already take the modulo, so that's why I just make it like that. Equal to k hai kya? Right? So that's the simple approach, right? Okay. So yeah, it's over. Now your outer loop will again traverse one step ahead and is pointing to this, and your vector of t is pointing to single element, which is 3, right? Now, if you move forward, again you make a map, and your map is empty right now, right? Which is map. Okay. Now, after that, your j value is y modulo of k, which is 3 modulo of 3. This is 3 now. Y is pointing to this. 3 modulo 3 is 0. Now you are searching k minus 0 is present, means 3. No, it's not present because it's the first element which we have, right? We are pointing to the first element. So it's not in the map. This checkpoint is not satisfied. Now map j is 0. I simply incremented. After that, my inner loop will finish, right? When your inner loop will finish, your outer loop will also finish, right? Because we are traversing all the vectors, right? All the lists we are already traversed. Now, whatever your answer, simply return that answer. So that's the simple approach, like how we can solve this question. So I hope you do this question, right? So this is a simple, like we just have to find the pairs, right? Pairs of two elements, right? Yeah, many questions you are solving that part. So that's a simple approach to solve that question, because we have multiple conditions to satisfy. So that's why that's the idea how we can solve this. Okay. Now let's see the code part. So similar code, what I am written here, we have to write here. Okay. So the first step I as already tell like you. So you just have to make a map and which is of type int, right? So that's the your value array I array j. When they both are equal, you just have to do the indexing part in your vector, right? So here the condition is right. So map of array of I, just push that particular index I plus one because I want the indexing in the one base, right? So that's the first step where I am satisfy the first condition of this array I equal to j. I just simply collect all the values, all the indexing where the values are same, right? Where the values are same. Okay. Now, after that, I just make a variable 0 and I'm traversing over my map, right? My map contains int and vector, right? Now, inside this, my value of map will be in the form of vector. Now, again, every time I just make a vector which is name as t and is pointing to x dot second, right? After that, I again make a map of it which is of int type, and I simply traverse my vector, that particular vector, which is j or y pointing to t, right? Because the vector is t. Now, inside this, what we have to do is the current value is j, right? And I'm asking, hey, k minus j is present in your map or not, right? So that's the value of I, right? As I already take the modulo of it, so that's why you just have to take the plus sign, I plus j equal to k, right? So here I have written, hey, if ki is present in your map, so please give me the count of it, and that's the pair which we are formed with the help of ij, right? So I just make the count of it. After that, simply add the value of j, right? Why j? Because that's my current value. Because I the index I this value as I already searching in the left direction, right? But my original value is j, right? Okay, when this loop is finished, and after that this loop will finish, all the pairs count will be stored in your answer, right? That's my simple approach to solve. So it's a two-step problem. First, you just have to segregate all the values. Based upon your values, just to make a vector of similar values, right? Based upon the indexing part, and after that, just have to traverse it and count it. Now, can anybody tell me like what's the time complexity of the solution? But I am telling you, what's the time complexity of the solution? Okay, so let me tell you. See here, in the trial part, what I'm doing is I have this five elements, right? Now, in the first part, my x is pointing to these two elements, right? Inside these two elements, what I'm doing is I simply traverse this first, this first. Now my inner loop will finish, right? Again, my x is pointing to this, and you have the vector this 2 4, right? And your inner loop will pointing to 2 first. After that, it's 4, right? Again, your x is pointing to this. Here, your inner loop will pointing to 3 itself. If you see here, we are using the 2 loop, but we are traversing each element one time, right? That's why its complexity is big of n, right? Its time complexity is big of n. Because you are traversing, you are just checking your element one time. Here, it's big of n, right? Here, if you see, so if you see as a random of this part, so you think like, okay, so its complexity will be greater than big of n, but it's not, right? As I already tell you, like we have the n elements. In this two for loops, each element will be traversed one time, right? So that's why its complexity will be big of n. Okay. So time complexity is big of n plus big of n. That will be 2 into big of n. We can say that it's big of n, right? So that's the idea to solve this. So yeah, if anyone want to ask in this part, he or she can ask, so that yeah, I know you are understood or not. Understood, please give me a +1 so that I can move forward to our last question, which is third question. Okay, so let's move to our next question. Yeah, our next question is this. Okay, so maximum answer. Here, what we have to do is you are given a undirected tree of n nodes and n minus 1 edges, right? Where we have three edge taking three things u, v, and w. U is the first, u to v is the you have the direction of it, and in that particular edge, you have the weight of right, which is w. Okay, so you just have to find the sum of maximum weight. So please understand this line carefully, right? You have to find the sum of maximum edges weight, maximum weighted edge in all the unordered paths in a tree, which have at least one edge, right? And unordered means simply if you have taken a u to v path, so v to u is the same, so you just have to consider one time, right? So yeah. Now let's understand with the help of this example first. Like how many of you are understood the third problem? I have to first understood the problem or directly go to the solution. Okay, ठीक है. So see here, our graph is this. Okay, so first example is this. Okay, so it's 3. Okay, so here weighted edges 2, here we have 3. Now see here, my n is 3, right? My edges are 2, right? N minus 1, we have the edges. Now if you see here, okay, so we want the maximum weighted, right? Maximum weighted. If you see here, 1 to 2, we have one edge, right? So 1 to 2, what is the weight? 1 to 2, what's the weight? So okay, 1 to 2, we have weight is 2. As I know that, right? In this edge, the weight is 2. I want the maximum, right? I want the maximum. Now, 1 to 3, we have only one edge, right? Which is 4. So let's take 4. Now, I have this direction also. Let's calculate for 2 to 3. Now, 2 to 3, we have two edges, right? We have two edges. Going from 2 to 3, we have two edges. But the question said you just have to take the maximum, right? We have this edge, you have this edge, you have this edge from this to this, but you have to take the maximum of it, maximum of 2 or 4. What is it? 4. Okay, so just club these values. What's your answer? It's 10. That's what we want. That's what we want. If you see in the explanation part, similar explanation will be given by them. 1 to 2 it's 2, 1 to 3 it's 4, 2 to 3 it's max of 2 to 4, right? Either 2, either 4. What's the max? It's 4. So just take the 4. And after that, just club all the values and return that answer. Similarly, in this case also, 1 to 2, we have 1, right? 1 to 2 to 3, 2 to 4, we have 3. 1 to 3, we have 3. Now, 1 to 4, you have two edges in that particular direction, right? Just take the max of these two. If you see here, 1 to 4, 1 to 4, max of either 1, either 3. What you are taking? 3. Okay, again, we have 2 to 3, 2 to 3, 2 to 3, this edge, this edge. We have two edges. The question said take the max. So what's the max? It's 3. Let's take 3. 2 to 4, we have only one edge. That's why we take 3. Now 3 to 4, 3 to 4, this edge, or 4 to 3. We have three edges, right? 4, this edge, this edge, this edge. Just take the maximum, which the value take max? 3. Let's take 3. Add all the values. That's your answer, which is 16, right? So I hope the question is clear. Yeah, you can do without modulo, but in that case, you just have to take how you can take the multiple of it, right? You need the multiple now, right? So you just make it as a like without modulo. If you take the without modulo of k, so in that case, how you can solve that part? Just checking the value of I is present or not in your array, right? I just make change the value like I plus j. No, it's not this topic. Somebody asking me, okay, like I plus j ka modulo k equal to 0. So that's the question. So that will be changed by us like I plus j equal to k or not, right? That's the approach. Okay, so hope you understand the question. Let's understand how we can solve this step by step, right? The code is very lengthy, so let me tell you with the step by step part. Now, so before telling to that part, if you are not comfortable with the that disjoint part, DSU part, so it's very hard to understand that question, third question, right? So that question is simply based upon DSU, right? Disjoint set union. Okay, so my request to all is like if you are not comfortable, so first just understand the basics of DSU, right? Many of students like skip that part, but that particular question is depending on that, right? So after that, if you are comfortable with union and find function, so after that you can come up with this recorded part, right? After that it will be in the recorded part, right, in the GFG practice channel. So after that you can join this third question and try to understand it, right? Because if you are not understood the DSU, it's very hard, right? So that's why I'm telling you. Okay, so yeah, so let me tell you step by step how we can solve this, right? Now, I want the maximum. Please make sure when you have multiple values, multiple paths, you just have to take the max, right? After that, I tell you very basic thing like how we can solve that part, right? Max part, right? Okay. Now, let me make another graph. So yeah, this is our graph, which is look like this, right? Now let's see. So in the DSU part, as you know, like we just have to take the parent array, right? And also take the rank of it, or we can say the size of it, right? Size means just how many particular elements in a particular like graph or tree you have, right? So let's make first parent array. This is a PAR and this is a size part, means rank part, right? So let's make it this first. So how, what's the value is? N is 3, right? So let's make the size 3 and this is your PAR, right? So in this case, what we have to do is N is 3, so just take the size 1 plus. Okay, now this is your parent array and this is your size array. Okay, so previously in this part, like you have this 0, which is pointing to itself, 1 is pointing to itself, 2 is pointing to itself, 3 is pointing to itself. Now, these are the nodes you have, right? These are the elements you have. Now, what is the parent of 0 itself? 0. What is the parent of 1 itself? What is the parent of 2 itself? What is the parent of 3 itself? Right? So I am storing that part, right? What's the parent of 0? It's 0. What's the parent of 1? It's 1. That's why it should look like this, right? Now, the parent you have, right? Now, the size array just stored in the particular tree. How many elements you have? Okay, one, one, one. That's why I take the size of that, right? One, 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 one. So I hope you understand these two steps, right? So in this case, what I'm doing is size is n plus one ka size, n plus one ka size, and all are of size one. And here I'm taking the pair, which is parent array n plus one size. And inside this, what I'm doing is I simply make pair pair of I equal to I, right? That's the particular parent of that particular index, right? So that's why we have to take. Now, our next step is we just have to sort my edges. Okay, we have to sort the edges, right? Why we have to sort the edges? Let me tell you afterwards, right? When we are at the end of our dry run. Now the first is 1 2 2. Okay, so we have 1 2 2 1 3 4. 1 2 2 1 3 4 we have, right? Okay, so okay, now this is your u, this is v, this is w, this is u, this is v, this is w, right? Now this is the fashion of it, right? Okay, now what we are doing is, if you see here, this sort part is based upon the second value, weighted value. So as you see, array of 2 is less than b of 2, right? It means that your this array will be sorted in the form of weight, right? In the weight of weight. So if you see here, yeah, it's already in the sorted form. Okay, so 2 came first, 4 came at afterwards, right? So it means that will be sorted based upon your weight. Okay, so we have in the sorted way. Okay, now after that, what we are doing is I simply traverse on the edges part, right? So what the first value? As I will tell you, u, v, w. Now, if you know that in the p part, what I am doing is I simply make the union nodes of it, right? So in this case, what I'm passing uv, right? So I have function uv. U is, now I am pointing to this. U is 1, this is 2, right? This is u, this is v. Now, after that, my control go back to union nodes. Now, I am in the union nodes, right? I am in the union nodes, this. So, this union node simply tell me like how many size, what's the size of your v, what's the size of your u, just simply give me in that in the form of pair, and that pair will be stored in p part, right? So let's do that afterwards. So as I already tell you, like what they return, right? They just return the size of that particular u and v, right? Here I am replacing u and v as x and y, right? And we have the parent array and we have the size array, right? Now, after that, what I'm doing is my px means my parent of x. Okay, so what's the parent of 1? What is the parent of 1? Here we have, here we have the array. Parent of x means 1. It's 1, right? It's 1. So that will be simply tell by your find function. Here am I, as I already tell you, like we just have to find the find function, right? Find pair. Please find what is the parent of your current value, means x value. So that parent will tell me like what's my parent array, right? So if you know the DSU, I hope you know that like it's a basic part, right? It's the first step of the DSU part. Okay, so I uh, I hope you know that, right? Who are watching right now. Okay, so what is the parent? Parent of this is 1 itself, right? So px is 1. So I am storing px equal to 1. So what is py? Py is calling for 2. So what is the parent of 2? It's 2. So what I'm storing here? Okay, so py. Parent of y is also 2, right? Now, after that, if I have px, I have py. I can already find what is the size of that particular x and y, right? Here I am written x s, s of x, size of y. That will already calculated with the help of size array, right? Now I am asking, okay, size of x, size of y. So what is size of x? Okay, so 1. 1 ka size is 1. So that will be 1 here. So what is size of y? That will be 1, right? That's also 1. So let me write here 1. Okay. Now we have one size, we have one size. So it should be look like this, right? It should be look like this, 1 1. As I have a node this right now. And what's the weight here? 2, right? This one. Okay. So I have one size here. I have one size here. Now I just want to make a path compression of it. Now what I'm doing is, in this case, I just make and club that part, right? So both of the value are same or equal to. So what I'm doing is, this is my px, this is my py. So what I'm making is, I simply make that particular element as my parent. So 2 ka parent is, px ka parent is 1, means px. So here I am written that. So if your value of x, size of x is greater than or equal to xy, so in that case, I simply make parent of py equal to px, and I simply increase my size. So that will be the fashion of it. That will be the tree of it. If I make, this is my px, this is my py, right? And I am already make this. So now your size of px will change, right? So that will be added with the help of here size. So what is px here? Px is 1. Okay, so px is 1. So what is your size of this? It's 1. So let me add this plus this, which is 2. That's why what we are doing here in this case, okay, I just make the parent of py equal to px. After that, I just increment my size of px. Why? Because I connected py with my px. So if I connected that particular tree with my px, the size will also increase now. So that's why here I am written px ka size plus equal to size of py. What's the size of py? Is already clubbed in the tree of your px. That's why size increase, right? Okay. So here my size increase, right? If you see here, 1 ka size, 1 is your root, right? What's the size of it? It's 2. Already updated. Now it's high time to return. As I already tell you, like if condition is satisfied, no need to go into the else case. Return x, y, and x size of x, right? So what is the size of this? What is the size of this? Already stored here. Okay, so I am returning that part to this case, p part, right? Now my p is stored. Okay, your value is 1. Here your value is 1. So I am segregate. So what is the size of u? It's p dot first. P dot second is size of sv, right? So we have 1 1. So what I'm trying to tell you is, when I'm making this node with this, what is the size of this? What is the size of this? It's 1. It's 1. What is the weight? This is 1. This is 1. What is the weight? It's 2. Multiply this like this. Answer plus equal to, what is SU into SV into W. That's the answer. What's the answer here? Answer is 0 plus 1 into 1 into 2, which is 2. So my answer is 2. Right? So up to here you are able to understand. Okay. Now after that, please be in the line. Like now you are understood like why we are sorting this, right? Now after that, I am pointing to this. If I am pointing to this, let me erase this, or yeah, let me erase this. Now your u and v is 1 and 3, right? You have 1 and 3. If your u and v is 1 3 now, let's call for this case. What is px? Parent of 1. What is your parent of 1? Now your tree will be look like this, because you want to connect 1 with 3, right? Your array will be this. Sorry, your tree will be this. 1, 2. Now your 3 will be this. You just want to connect with this, right? Okay. So this is itself its parent, or its parent is itself, right? So what is px? It's 1. What is py? It's 3. You have this. You have this. What is size of x? So this is your x now. What is size? It's 2. It's already stored here. What is size of 1? It's 2. Let's take here. What is size of 3? Okay, let's ask from it. It's 1. So let me add here 1. Now, now. So this is 1, 2. This is 3. Now this size is greater than or equal to this. So based upon your path compression, I hope you know that path compression, right? What you have to do is, okay, so this size is increased, this is less. So you don't want to increase your height, right, of tree. So that's why I just make this here. And in this case also, what we are doing is parent of py is parent of x. That's the simple approach to take this, right? Why? Because if I have this and I am clubbing with 1 here, your size is 3, your height of tree is 2. That is the idea of path compression, right? You just have to compare which size is greatest. Okay, so this size is greatest. That's why, okay, that will be your parent and that will be your child. So here I am making like that, right? Okay, now how many size of x will be yours? It's of size 2, right? It's size of 2. Okay, we have 2 size, we have 1 size. Now I have w, for this case is 4, right? 4. Now if you see clearly, okay, we have 2 paths, we have 2 nodes here, we have 1 node here. If I make addition here, how, what's the weight here? It's 4. I already have answer as 2 as previous for this case. Now when I connected this case, I know that the weight is 4, right? But I also need, this is also connected with this, with weight 4, with weight 4, right? I also want that. That's why, that's the main motto of us. Calculate how many nodes here? 2. How many nodes here? 1. Multiply that with 4. That's your answer. 8 in that case. Because if you connected 1 and 3, 4. If you want 1 to 3 is 4, 2 to 3. Okay, this is 2, this is 4. I want the max, right? What is max? Which is 4, right? That's why what we are doing is, okay, calculate the size of x, calculate the size of y, multiply this both and multiply the weight itself. Multiply the weight itself, right? That's the main motto of us. Like, we just want my array, my edges array will be in the sorted form based upon your weight, right? When I move forward, so let's suppose when we move forward, your weight will be 8, and here it is 3, and in the y part, for example, we have size 2, this 2. So what I want, count how many nodes we have, 3. How many nodes you have, 2. So 5 into 2, sorry, 3 into 2. We have 3 here, 3 into 2. What's the weight? Let's suppose it's 8. Multiply by 8, because I want the maximum, right? I want the maximum weighted edge, right? So that's the simple idea why we are like sorting it, and why we are counting it. What is the size of x? What is the size of y? Multiply this, multiply the maximum of weight, right? Which is currently weight. Current weight will be max. That's why that's the idea of it, right? So let me tell you again how we are solving this. First is parent array we are making it, right? Which simply tell us that that particular child ka parent is who, right? So that's the parent array. So just tell me like the size, right? So it's very crucial, right? Because at the end of the day, we just want the size of x and size of y. Based upon that, we just make a connection of it and uh, calculate the maximum weight. So parent of particular is 0. Parent of I equal to 0 to n. So that parent of I equal to I. That's why we are sorted, because at the end of the day, I want the maximum. So yeah, that's the main motto of sorting part. So in this case, what we are doing is I have U, V, W and make the union of it. Go into the union part. Union part simply give me the, after union part, what's the size of X, what is the size of Y, they just simply give me that. And with the help of this find pair, I simply find what the parent of that particular node we have, right? That's the simple idea of parent, right? So based upon this, we just club that part based upon our path compression. At the end of the day, I just return X, size of X and size of Y, which we are stored here. And based upon that, we segregated the p dot first, p dot second. At the end of it, I just multiply that part. At the end of it, I just return that part, right? If you see here, in the first case, my answer is 2 when my this part is running, right? When this part is running, my answer is 8. And at the end of it, what I want, 2 plus 8, which is 10, right? That's my answer. So, yeah, this is the simple approach to solve that, right? Yeah, it's not simple. Okay, so if you are not familiar with the DSU part, right? Uh, so again, I requesting you all, please, understand the basics of it, like find path, right? Path compression, find function, union functions. If you are comfortable with that part, yeah, it's very simple for you guys, right? So yeah, it's not that much time. Like if I explain all the things. Okay. So yeah, that's all from my side. So if you want to ask anything, you can comment. Yeah, chat session. Okay, so let me tell you the time complexity of this also, right? So what's the time complexity? Here we are running the loop, right? Here we are sorting it, right? So the first case is big of n, and after that we are sorting it. Let's suppose it's n log n, right? Yeah, it's n log n. Okay. Now after that, what we are doing is we just traversing the edges part, right? Suppose that your edge will be the size of m, right? So here let me write m, because n will be different and edge will be different, right? Now here we are m into, okay, so we are calling the union nodes function, right? So that function, if you go forward, that function will call find pair, right? So the find pair is amortized of n, right? We can say that yeah, we are just going to the parent, so it's log of n. Okay, so that's the complexity of it, right? Okay, we will be having single paths between two nodes. Yeah, we will have single path. Like if you have the double path, like you have the single path, right? And in that particular path, how many edges you have, right? For example, you have two edges. Just compare the weight of it, which weight is maximum. So that particular path, you have to take in that particular edge, right? Because I want the maximum answer. Okay, so yeah, this is all from today's analysis, right? If you have any doubt, you can also visit again that recorded session. Yeah. So if you like it, please like that session. Okay. So yeah, please comment below if you have any doubt. We are happy to answer that. Right. Okay. So thank you so much, guys, for joining today's session. Right. So yeah, at the end of the day, I also tell you like if you are not familiar with like advanced data structures, so it's high time like summer sale will be there in a GFG session, so you can join that particular uh, course, right? As I already tell you, this is the coupon code of it, right? Again, I am sharing with you, right? You can use that coupon code and you simply get 30 to 35% discount on that particular courses, right? So yeah, that's it from my side. Thank you so much, guys, for joining today's session. Good night to all. Thank you.